Hey, good morning, everyone. So thanks for being here, attending the fourth webinar of the BIM4Ren project. So BIM4Ren is a European-funded project, and we are working on using BIM for renovation, and in particular tackling energy performance innovation of residential buildings. So we already had 3 previous webinars where we saw how we can collect information from existing buildings and much more. And today we are going to see how we build up a fully informed model of the existing building and what we can do with it. Yeah, just to start working with this this model. So I'll give the microphone to my colleague Michel Böhms from TNO, who will give you a brief intro on this fourth webinar.
Okay, thank you, Pierre. So this is already the 4th episode of a series called BIM4Ren's Added Value in the Energy Renovation Project. My name is Michel Böhms from TNO. It's the largest R&D institute in the Netherlands, and I will start with a short introduction. As Pierre already mentioned, we already had 3 episodes. The first one, the general one, explaining the project, the context, philosophy, challenges in general sense. The second one focusing on creating geometric models from 2D layouts via 3D scanning, point clouds, etc. And an episode on the non-geometric data. How is that inputted, especially from textual documents that are available and on-site visits. We are not going to redo that information. If you want to still see them, if you didn't have the possibility yet, you can all find the right YouTube links on the website that you see there on top. In this session, we will focus on the actual data management aspects. And these data management aspects, they sit nicely between, say, the data collection, the digital inputs that you have for that data management, and the actual exploitation of that BIM data. We refer to that as the data-driven analysis and design. And in the middle, we have to consolidate all these data sources. We have to enrich them, and we have to check them. We have to validate them. Are they for the right purpose? So this whole session will be focused on functionalities and data aspects for this middle part. For this data management, I want to introduce some of the principles that we have. And these principles, they hold for both the data and the functionalities and the software. And the software can be open source or can be commercial, common off-the-shelf software. But all the things we do there are relevant for both these aspects. And the first one, the primary one, is everything is cloud native. That means that everything we do is built on top of internet web technology, or said otherwise, it's happening in the cloud. And the other thing that is quite specific to maybe to this project is that all the data and the inputs and outputs of services are as semantic as possible. And with semantic, we mean that the data is defined in specifications like schemas, ontologies that give clear meaning what is possible and what is impossible to the data. And furthermore, all our data is what we call fair and future-proof. And fair, you find it on the bottom. It's a well-known acronym for making data findable, accessible, interoperable, and reusable. And to be able to reach that, you have to stick as much as possible to open standards. Well, some of you might know of the acronyms behind there. The Building Smart IFC standard is a major one. GBXML, especially for energy aspect, but also W3C standards like the building ontology topology, and several SEN standards like for the data templates and semantic modeling and linking guides that we have there. And the main issue that we target actually in this project is, yes, we can create BIM models and we can create open BIM models in IFC, but typically, and or I would say often, this is not enough for using them. We need to enrich them and check their usability for different purposes. In this initiative, we typically do the following steps. We take those IFC step files and we transform them to linked data. Linked data, the distributed technology from the web, where structured semantic data can be handled. So the corresponding specification is the IFC OWL specification. And we also extend this specification to get in the end a BIM4Ren data model that is and that makes it possible to enrich the data that we want. So we use that for enrichment and checking the data. Important also to note is that when we talk about enriching, it's the enriching of the as-is situation that we have with energy aspect, not yet available in IFC directly. And of course, also the to-be situation, the different renovation scenarios. What kind of measures are taken? Is the class, is it changed? Is it an installation component changed? That kind of BIM updates actually for the actual renovation. And then, of course, after we have done the right analysis and design steps, and we want to consolidate those changes, they are actually chosen changes, we want to be able to feed them back to the original IFC step files so that they can be taken into account for further life cycle stages like the actual construction phase and in the end, the operational phase. Finally, all these services that we're talking about that we develop in tools are available also in open ways. Open API-based specs, they become virtual web services and applications, typically Docker containers. Also involving what we call BIM bots. That was already a term in the title of this presentation. And I say shortly about this BIM bots. You can see that as a kind of, we call it BIM-oriented semantic web service, a microservice, where we clearly specify in a semantic way also the inputs and the outputs of these services. As you see on the right, you can form networks of these BIM bots where the inputs and the output are in standard ways described, giving their ID, the location, where can they be found and executed, what is their semantics, what schema or ontology is used to define them, and what is the actual format, the serialization of the data. All this stuff, all this meta information on inputs and outputs is defined, of course, also in standard ways, in this case in a JSON way. And you see an example below there of a specific BIM bot that is specified, the Shekel model checker. Madhu will tell later about that. And you see how inputs and outputs are specified in certain ways. You can identify an IFC file. You can say something about the data model, about the type, etc., etc. And the different output files. In this situation is the BCF file, the BIM collaboration format file. In this session, we will show you some, say, sneak peeks. It's really development work, everything, but we want to give you an update of the kind of things we're working on. We start there with the IFC step files, obtained via traditional ways, via authoring software, parametric design, based via GIS-based generation, where heights are added in a sense, or 3D scanning, and IFC is generated from these point clouds. And we will show you sneak peeks of the following steps. First, Bruno Fiès of CSTB in France will show you about the enrichment process and the preparation of the renovation scenarios. Next, Madumitha Senthilvel from Aachen University will show you how we can validate, verify this enriched data using a technology called Shekel, one of the components of the linked data stack. Next, Jyrki, also from Aachen University, will show how we can feed this information back to the original step data. And then, of course, you have seen already quite some functionalities and stuff that we want to make into workflows. We want to orchestrate this stuff. Then my colleague Joost Adriaanse will show you about the Maestro BOT there. Finally, Pierre will come in again and show you the big picture, the global pictures, and draw conclusions from that and the future. BIM4Ren, he is actually the technical lead of BIM4Ren for the total view there. Before we start, I want to say that if you have questions, if questions arise, please use the chat box for that in parallel. In the end of the sessions, we will make some selection of these questions and answer them online. And if time is not available anymore, we do that afterwards. So please put any question in there. But first, let's move to Bruno, who will tell you more about the renovation process. Thank you.
Thank you, Michel. Hello, everybody. My name is Bruno Fiès from CSTB. Let's start with a few slides before the demo. So as Michel has introduced already the topic, I will present you the Lodlifter, which is a tool we have developed in order to enrich the IFC file coming from previous step in the data gathering phase. So the ambition of this Lodlifter is really to bridge the gap between the IFC file that were defined by different techniques, on-site scanning or parametric techniques, and the simulation tools that need really specific and accurate information, different properties well defined. And we have seen that from these techniques, scanning or parametric technology, the IFC files generated are not accurate enough. This tool, the Lodlifter, is composed of two main components. The first one is an automatic component, an automatic retrieval that will retrieve various information, mainly from external cadastral databases. And the second component is a manual component. This will be the main demo. It will be on it, and it allows users to pick from existing catalogs of product, to pick products from there, and to replace the existing initial entities in the IFC file by these new products that are well defined and are coming with a lot of property well defined. In order to produce this catalog in the frame of BIM4Ren, we have developed also all the chain. So we have developed the catalog editor. We have developed it following the ISO 23386 standard. But today we will only talk about this Lodlifter tool. So now it's time for the demo. So I will do it live. So this component, this Lodlifter service, is something that is available through our OSAP platform. Okay. And this OSAP platform is based on an existing tool that is Croquis that CSTB has developed previously. Here we have put all our files coming from the different pilots. Today we will use the French pilot, so I can navigate through that. We have two sites I will select. So I have selected the Dunant site. Then corresponding to the result of the scanning, on-site scanning phase, I have several IFC files. I will take this one. And now I will use the service called Lodlifter in order to enrich this IFC file as I introduced. So this is the Lodlifter environment. So what is happening at the moment? This IFC file is translated into two main formats. The first one is via an IFC all transformation is stored in a triple store, and the second transformation is just to have this interface capabilities in order to manipulate it. This is something that is done under a Cesium environment. So now I have here a representation of my IFC file. I can play around with it. I will start with the Lodlifter 1, the automatic retrieval. In fact, it has been done automatically. What I can do only is to check what has been done. So here I can check what are the information that were automatically retrieved from external databases. So I have the composition of the building itself. I have the number of parking places, for instance. I have also an indication that the load-bearing walls are made of stones. I have tiles on the roof. I have some surfaces information, year of erection, and so on. So this has been automatically retrieved and assigned to the building itself. Now I am here in this environment, and as Michel mentioned, I focus on the scenario that is the as-is scenario. I have gathered a lot of information on site, and now I will add it to my to my building. So here, for instance, if I click on one element, I have selected this wall here. You have on the right-hand side all the information that are attached to this entity. And as we can see, we have only two properties, one ID and a name, which is very poor. At the same time, on the left-hand side, what I have is my catalog of products listing all the products that are compatible with this wall that I have selected. And for instance, if now I'm selecting a window, again, on the right-hand side, you have all the properties attached to this window. So this is something that is poor. And on the left-hand side, I have my catalog of windows, and I can check all the solutions that are available to replace this poorly detailed window by another one. When the expert was on site, he had an idea of what are the let's say overall properties and performance of the window, and as such he has defined a kind of generic window reflecting more or less the performance of the as-is window, the windows that are installed on the building to be renovated. So now I will then assign to my building, to my geometry, I will assign here the window, this generic window. So I click on this button, say assigned, and then this window that were previously not defined now has all the characteristic of this generic window. Okay, now imagine that I can do everything like that on this model, and now I will also work on a new scenario. Michel was mentioning the to-be scenario, so let's define a new scenario, for instance, called Renovation 1. I'm adding this scenario. Okay, I'm now working not anymore on the as-is situation, but on the to-be situation. Okay, you can see here this new scenario, and let's say that now I will apply on my entire external walls an insulation solution. So I can select here the wall building element. Okay, and if I click on one wall, in fact, all the similar elements, so that means all the external walls of my building will be selected, and then I can apply with one click one insulation solution to this building. So for instance, this one, I click on assign, and it's processing, and everything, in fact, when I'm clicking on assign, everything is processed, and it's stored on triple store, where in fact my colleagues can retrieve this information, this enrichment, via an API. Okay, this is done, and now all my walls have the same insulation characteristics. Okay, so you have seen how we can enrich the initial IFC file via this simple interface, and everything is stored back in a triple store in order to be available for treatment. And that's it for the demo. So now it's time for me to give the floor to my other colleagues. So
Okay.
thank you.
Okay, Bruno. Well, thank you very much to showing how we can extend the original IFC data, and how Madhu will actually show us that this information, this enriched information, if we want to check that for certain purposes, what are the possibilities there? So please, Madhu.
Thank you, Michel, for the introduction. I hope you can see my screen now. So I'm Madumitha Senthilvel, a PhD student at RWTH Aachen University in Germany, and I'm going to continue the story from the previous presentation. So Bruno showed you one of the tools that we use to enrich information. Of course, in this project, we use a variety of such tools that use different kinds of data, enrich them, and spit them out for other tools to use. So in short, we have the series of interconnected tools that communicate with each other based on the information each tool sends to another. In this case, one of the things that we have to make sure is that the data that is being given as input to another tool has all the necessary information, which means we have to make sure that we catch the errors in the data, check for any missing information in the data, and also make sure that if a tool is giving an output of information, this tool, we have a mechanism to check that it has all the information required for the next tool to use it. In short, this would look something like this. For example, a most common example is that if we have a wall element, we check for the property thermal transmittance. Is this property present for all the walls in this model? The second way could also be that if there's a thermal transmittance property associated with all the walls, is this value within the range that I would like for my tool to work properly? These are the common kinds of checks that we would like to do in this project. And if we are able to do these checks, then we have automated checking processes that check between each tool the output of one tool before it becomes the input of another tool. So in short, we have an automated checking mechanism between tools so that there's a seamless chain of tools that use each other's input and outputs. Of course, the AEC domain has its own set of validation mechanisms, the most popular of which is to simply check an IFC model using an MVD XML file. Most of you who's worked in this domain would probably know this. And an MVD XML file usually checks and gives an output for which information is missing from an IFC model. But the issue here is that if we were to check for graph data, such as link data graphs, that is what is the main issue in this project that we are looking on. Or if we look for information that is connected to this graph data, such as images or information in spreadsheets, then the MVD XML method is not applicable anymore. So herein comes the approach that we adopted in this work. We looked at a technology called Shackle. It stands for Shape Constraint Language. It's a W3C recommendation which came out some years ago. And in this technology, there's two kinds of information that we Of course, then it comes to what exactly are we checking? Because this is so broad, we fix the types of checks that we would do. The simplest is just saying whether there's a property that exists in my data and that this property is only present as one instance. For example, all walls should have only one property thermal transmittance value. There's no multiple thermal transmittance property. The second one is to check that the value of this thermal transmittance is an integer and it's not a string or any other type of data. The third one is specifying that it's within a specified range that the user wants. And of course, we can go more complex and ask if all the walls only in the first floor have this thermal transmittance property. And the final one is also to check a subgraph pattern within this graph. So these are the 5 types of conditions that we check for in the data that we get out of some of the tools that use linked data graphs. And the ongoing research, which is the major contribution in this work, is that given that we have technology such as Shackle to validate linked data graphs, there's very limited options for creating these graphs. That is, to create these constraints, there's not much of open source tools available. And this is the bottleneck in any kind of constraint definition language. So what we look at in this work is actually if the user can determine which target, which classes to check, and what is the property to check. We have created a user interface where we have a visual representation of the Shackle constraint. And the user just has to select which applicable target class is they want to check, what is the property they want to check, and what is the cardinality or the data type. So the language of Shackle is masked behind this visual nodes. The user does not have to know the coding language per se. So this makes it much more easier for non-domain experts to use this type of a constraint language to check the data. So we have implemented an initial prototype that's already available on GitHub when this kind of visual programming is used to generate constraint files. And this constraint file actually works as a input where we push all the files that is generated out of this into a GitHub repository that's open source. And then this repository acts as an input for the checker bot, where we check every time that a tool generates a RDF data, we check using this checker bot. So the key contributions from this work at this point is that we can check any kind of linked data graph using the Shackle technology. And the development of this constraint creator tool helps all necessary stakeholders involved in the project to use them to check whether their data is adequate. And finally, the checkerbot automates this process of checking. So it directly pulls all the required constraints from the GitHub repository as and when needed. And with that, I would end my presentation and hand over to the next presenter.
Thank you very much, Madhu, for your interesting insights. So now that we have enriched data and we can actually check all that data, suppose we are happy with it and we want to feed it back to our original IFC step files. How can we do that? Jyrki will show us the way to do that. Okay, floor is yours.
Okay, yeah. So, can you see my screen?
Yep.
Okay, good. So I'm starting with the internal data model. We have the enrich data sets which has all the connected information there, and there are lots of applications that need to have the data, but they use the IFC format, and there's the need to convert or save the collected information to the data model. And luckily we have the situation that there are the global identifiers in the models, they are shared with the original building models. So if there are any additions or edits or deletions in the model, the same apply to the building model itself. So we can do it efficiently, so that we have the saved original model, and we can edit it. It's the most efficient way to do it. So if you have an added parameter which is connected to one building element, we add the same parameter to the original building model, and in that way we can share the new value. And if there are any new or deleted building elements, the same apply. Yeah, we have the use case here. So to add the thermal transmittance property value to a window element in the model. So we have got the general changes, which is describing this change, and it's having the GUID for the element, the global identity for the element. So we know where to add the new property. And yeah, we have the implementation, and this is showing the original model, the input model using Solibri browser. So you can see that it's not existing here yet, and after the update, we have the value. So we have been testing it, and it's possible to add the values. It's for the window element here. But you need to recognize that it's when you adding some values, they are in ASCII file connected to property sets with standard property sets. And then when you're updating values, of course, it's very easy. You can find the property set where to apply the change. And when you are removing a property, it's as easy. You can remove the one. You can find the one by name. Of course, if it's the last one in the property set, you need to remove the property set also from the file. But yeah, there's a special case here when you add value and it doesn't exist in the model in the first place. So in the general changes, you have the GUID for the element. You can find it, but then you need to know which standard property sets you're using. So that's why we use the Building Smart Data Dictionary, for example, to know where to add it and what data types to use. And we can use the identities for the elements to add or edit values. Of course, we can use also the IFC class types. It was tested and it functions, so that in the test we changed values for all the windows, and the result was that yeah, it was functioning. So that was a quick introduction for the data save into IFC step files, and it was shown that it's possible, and it's much more efficient to edit the original model than to create it from the beginning. The global identities can be used there, and it's you need to be careful when you are adding new data, so that you have the same data types and data units and the correct property set, the standard sets in use. But it can be done. So that was my short presentation. Thank you.
Okay, thank you, Jyrki. Up to now, we have seen, well, quite some sub-processes, some things that typically are executed after each other in a certain logical workflow. So you can also imagine there is some room for automation there and some orchestration. And Joost will now continue, especially in that aspect, how to bring these different parts together, and also in standard ways. So Joost, please.
Yes, hello. My name is Joost Adriaanse, and I will tell a little bit about work on workflow orchestration, which we called Maestro BOT. So what you already seen in some of the previous slides, that the concept of BIM bots is actually a kind of microservices approach of having multiple bots doing some specific algorithm or analysis. And in most cases, this can be even a whole network of multiple bots needing to communicate with each other. And someone has to start these bots, have to connect these bots, and have to check whether they generate data and output the data to the next bot, which is done in doing the next step of the analysis. So it's quite a complex task, which you really don't want to do manually. So a solution was provided using some overarching Maestro bot, which is actually responsible of implementing the workflow of multiple bots running in a sequence, or possibly even running in parallel, depending on the type of analysis you were performing. So in this slide, you can see a small example, for example, of the renovation workflow. There you also have some data you need to transform into linked data, for example, before you can do analysis. You can imagine if you have multiple bots for this, you need to operate them in a certain sequence and provide data from one bot to the other. And it's really something, it can be cumbersome, it can be prone for errors, human errors, especially if you use the wrong data input. So it's really something you want to automate. And a solution for that is Maestro BOT. So we have an implementation also for this. This is a kind of very high level schematic picture of the Maestro BOT. You see in the Maestro BOT in the picture on the bottom, which is also implemented like a kind of bot, but it's a bot which is able to manage multiple other bots and actually send data to other bots and receive data and use this received data as input for a next bot. So the Maestro bot is aware of the type of inputs needed for a specific BIM bot, and what kind of output is generated, and which of these output can be then transferred to inputs of other BIM bots. So and the Maestro bot and the BIM bots are actually run in Docker containers. So it's also easy to scale this whole environment and run this Docker containers on maybe even different servers. So it's kind of all the management then is handled by the Maestro BOT of running all these BIM bots. You can see that the Maestro BOT is configured with workflow. Could be multiple workflows at the same time, and these workflows actually indicate exactly what kind of BIM bot should be triggered, or what BIM bots will generate data, and how this data is then transferred or need to be transferred to inputs of other bots. So it's actually a very powerful mechanism, and it's also solving part of the complexity of having a large number of bots in the environment. So these are just a short list of the benefits you can see. Like it's for the whole microservices approach, it's nice to have these small bots, but and it's also important in microservices approach that you don't make bots too complex, so you limit the functionality, and if you need more functionality, you can make a new BIM bot for that. But to manage this all BIM bots and to orchestrate the whole workflow of multiple BIM bots connecting to each other, we need something like the Maestro BOT, like an orchestration of the workflow. So the BIM bots, the Maestro BOT is able to automate this whole workflow of multiple BIM bots. And it also makes it easier for you to have multiple bots because it will handle also the workflow. It means both that each BIM bot can be small because the number of BIM bots, it's not a real issue for the Maestro BOT. It would be maybe if you have a human interface to configure and connect all these BIM bots, it will be more complex to use 100 BIM bots instead of 2 or 3. But if you use the Maestro BOT, it's a relatively simple process because the Maestro BOT can manage a large number of BIM bots automatically. And the other large benefit is that if you have a complex flow of multiple BIM bots connecting to each other, so you can either implement this workflow functionality inside the bots and have them connected like a network, like shown in one of the earlier pictures. That's something that will work, but it requires then the BIM bot to have this workflow or part of the workflow functionality. So it has to know which other BIM bots will use your output as input, and all these kind of complex functionalities will need to be implemented inside the BIM bot if you don't have a workflow management like the Maestro BOT. So it's a big benefit, and you can make the individual BIM bots much simpler, and you put this workflow management one time in the Maestro BOT. And this Maestro BOT is also then able to monitor the whole process flow. So if there's some hiccup somewhere, or some of the bots is not responding, the Maestro BOT will see that because it's monitoring the whole workflow. So you know exactly where things go wrong. If you have a network without a Maestro BOT, it will be more difficult to monitor the whole process flow. So it's also could be one of the big benefits of having a Maestro BOT. And another option would be to have maybe even implemented multiple Maestro bots. If you don't really like a specific workflow management of a Maestro bot, you could develop your own Maestro bot doing a similar thing. So on a single platform, you could have multiple Maestro bots implemented. So it's a very interesting concept, and I think it could help to reduce the complexity and make use of BIM bots much more easy for users and for someone managing the platform of BIM bots. And especially if the number of BIM bots is increasing, you will need something like a Maestro bot to manage all these BIM bots, inputs and outputs. So that was my short introduction to our work on the Maestro bot.
Okay, thank you, Joost, showing us how to put all the pieces together. Finally, our last presentation is by Pierre, our technical lead, who will actually take a step back and show how the puzzle pieces can fit together as a common global picture, and show us some stuff for the future within the project and beyond, maybe. So Pierre, it's yours.
Okay, thank you, Michel. Thank you, everyone. I tried to make it really short. Yes, just to give you the global picture of what we've presented. So in previous webinars, we saw how we could capture the geometry of an existing building. So that was basically webinar 2, and in webinar 3, we saw that we need much more than geometry, and we have documents available. We can go on site as well to collect information about the degradations inside the building or happiness of the occupants and so on. So we have quite a lot of information that we can collect when we start a renovation project. And the idea in BIM4Ren is once you have this information, what you want is to create a fully informed model. So a BIM model of your building. And yeah, it's not enough just to do that. You need to ensure that the model is valid, that you will be able to use it for your specific renovation, for the energy performance calculation, and so on. So that was really what we presented today. So we presented it into different phases. So first, Bruno showed how to enrich the initial model. So if you take the geometric model, initial geometric model, you can load it into the Lodlifter that was presented, and then you have some catalogs, and you can assign products to your elements, your building elements, and this way you get properties assigned to elements and so on. What was not directly mentioned by Bruno, but I think something quite key and original in our project, is that we log and track the updates that we perform on the model. So we have a specific format. We call that the journal of changes. And this way, it allowed us not to work with a full BIM model that can sometimes be really huge, but we just work with the specific sets of information that were updated or added on the model. Once you've done that, again, it's not enough. You want to validate the model, and sometimes you also want to convert your model into some different formats that are of interest for your study. So, for instance, JBXML for an energy analysis, but it can also be the IFC step file, as many tools are IFC compatible. So that was what Jyrki presented. So we have, yeah, we can develop. We already developed, but we can still develop much more services to validate, to convert, or do different things. And those services are what we call the BIM bots. What's important is that those services are tiny. They don't need to perform really huge things, but they just need to perform small operations that are really important. And those services can work directly on the BIM models that you have, but you can also perform like conversions on the journal of changes, for instance. And this is what we are doing to synchronize different models. So for instance, if you get the geometry, you can load it into the Lodlifter, but you can also, and this is what we are doing, you can also generate a GBXML version of the geometry, and then you can enrich your energy model with additional properties like thermotransmittance or others from the journal of changes and not from the BIM model. So we have this set of BIM bots doing all the work that we need. And at the end of the work, we have the orchestrator, so the Maestro BOT is in charge of designing the workflows and the sequences or our parallelism of execution between the different services. So, so that for different projects, you can have different workflows. So, yeah, some conclusions. So, yes, we use some we use quite a lot of linked data at the core of BIM4Ren. it allows us to have some flexibility and extensibility of the model. So it's quite handy for our project, because in the context of renovation, often you need to model some specific information that you don't have for new projects. The enrichment, so it's done mainly through the catalog of products by CSTB. We may need sometimes to have some manual intervention. So yeah, this is also another option. And what's important is that we have this microservice ecosystem, the BIM4Ren ecosystem, doing the small but crucial operations, and we have orchestrators and also the journal of changes. I think it's a really important concept in our workflow, so that we don't work with full models and versions of the models, but we work with a journal of changes. This way we can track the enrichments, but as it was demonstrated by Bruno, it's also a way to model your renovation scenarios. Yeah, so in the next steps, we will show how all of these concepts can be used further. So, for instance, to perform some energy simulation or to perform some life cycle analysis of the building or of the renovation itself. And this will be the focus of the next webinars we will have. So maybe time for some question and answer. Just a few words saying that we have a page on our website, so that you can join the stakeholder community of the BIM4Ren project. And this way, yeah, we have your email address, and if you want to test some of the tools we are developing, you can be on the first line, or if you want to take part of some of the workshops that we're organizing, and so on and so on, you can just subscribe on this page and yeah, be involved in the project with us. So that's it on my side. Thank you.
Okay, thank you, Pierre. So we are looking at the time. We are right on schedule. We're having some time left now for the actual Q&A for today. I looked at the questions that came in. There are actually 2 questions there. Let's see if there's more. No, I see specific 3 questions now. Actually, maybe the first one is already for you, Pierre. That
Michel, sorry, I couldn't hear you, so not sure. But okay, I could see the question, but which was about how to be involved in the project. So I tried to answer that. It's okay. So yeah, the project is closed. Can you hear me? No?
Yes.
Yes. Okay. So yeah, the project is closed. So if you're not a member of one of the participants of the consortium, we won't be. You cannot be involved in the project. I guess we have some problems with Michel microphone. Or
can you hear me, Pierre?
Yes. Yes. Now we can hear you.
R2M, can you hear me?
Yes.
Yeah. Okay, so that's it for the first question. I think there was another question for you, Jyrki. So what kind of tool do you use to update the parameters in IFC?
Okay. I'm creating everything using Java, but I'm using a BIM server library to edit the parameters. I'm using it also for parsing the data model. The originally IFC step file. Is that a good answer for you?
Yes, I think it's good. Thanks a lot. So BIM server used. Okay, and I think there was another question. Can I know how the journal of changes is maintained, and is there a specific format? So Bruno, perhaps you can say a few words about the journal of changes. Bruno. Okay, I can say a few words. Otherwise, if Bruno has some microphone problems.
There's some sound issue now and then. Can you still hear me now?
Yes, we can hear you.
Okay, okay, fine. Yeah. Now and then we are auto muted, but okay. Let's
okay,
continue.
so I'll give some words on the journal of changes. So is there a specific format? Yes, there's a specific format. We have some specifications for it. At the moment, it's quite simple, and it's a JSON file that we have. But I cannot say much more about the format. So basically, the idea is to have some concepts related to the kind of operations that was done on the Lodlifter, whether it was changing.
Pierre,
Yes.
Yes. I can talk now.
Okay.
So, yeah,
go
no, but
ahead,
okay. When the changes are made via the Lodlifter, everything is written in the triple store, and there is also a track of all the changes from the very first transformation. So this delta between the initial situation and all the changes made through the various scenarios is something that is stored in a triple store and can be then retrieved via an API. So it's just a matter of communication and following the API we have defined.
Okay, thank you. So we have some more questions. So Gonçalo Costa is asking to Bruno again. The information about the products, where does it come from? Is it from some public database, PSDD? Is it only for France or other countries?
Well, this is really open. The catalog you have seen is composed of several various inputs. Some of the inputs were coming from another European project, BIM Speed, in which also we are involved. Some of the properties you have seen, and especially for the French product, were coming from the PPBIM initiative. But this is totally open, and everybody is supposed to be able with this catalog editor to take the product sheets, data sheets of one constructor and to enter it through this interface and produce his catalog of product following this ISO standard that I mentioned.
Okay.
Okay.
Then we have the question of the enriching process by Elena.
Yeah. So in the enriching process, it was mentioned that the standard IFC properties were not sufficient to describe the object sufficiently. What kind of additional properties can be added? Are there any known standards for that? Okay, perhaps I can try to answer that one. Yeah, in a renovation project, there are some, well, the kind of specific information that we need is about the degradation, for instance, of the building elements. So you want to describe also the status of these elements. So I don't know if you have a crack, if you have yeah, I don't know, a leak or something like that, or yeah, any information about the degradation, and also some information about uncertainty. For instance, when you start a renovation, maybe you're not so sure about the composition of the walls and the type of insulation that was used, its thickness, and this kind of information. So there are many information like those ones that are required, and yeah, an extension of existing IFC is required. Are there any standards for that? Not to our knowledge. So this is also the reason why we worked on our own modeling.
Okay, so
maybe I can perhaps complement the answer made by Pierre, as in fact when I was talking about the need to enrich the initial IFC file is because this initial file is coming from the data scanning on site, and the resulting information is just the geometry. So it's very good in a sense to have again the geometry of an already built building, but we would like to have all the properties, and the scanning technologies are not able today to add these extra properties, even if we are talking about standard properties from IFC. So I would say it's both. We are enriching some IFC properties, and we need also to extend them with extra ones that are not supported by IFC.
okay, well, in the end, there is one extra for you, Bruno, by Consul Costa about, it's more about the energy analysis itself, maybe the concept of energy conservation measures. Is it similar as in the optimal project you might know of, I guess?
Well, we have not taken already into account such concept of ECM, energy conservative measures at this stage. I'm not sure I can answer the question, in fact.
Okay, well, and maybe then finally, my colleague Elena also mentioned, I think with respect to the properties, that in Holland we have several standards that sometimes define these structures and properties and how things are built up in product breakdowns. Good example is the NEN 2767 for inspection. So this is the way how people store their data from inspections. So I think there are properties everywhere, but not really in one systematic way. So there are many properties there, but we have to select the right ones and to model them in the right way and to connect them, I guess. A lot of work to be done. Think, looking also at the time, we are a bit later than planned. We have to finish this episode. So this actually ends our fourth webinar episode of this series, and I would say I speak for all of the team that we hope you enjoyed it. We thank you very much for your attention and your feedback and questions. We will send you a survey soon, so please tell us what you liked about it, what you did not like, whether it was too global, too specific, too detailed, too simple, whatever, so we can learn from everything. In the meantime, have a look at our website. You do not only see the previous episodes, but also you can stay in touch with us and with our latest developments in the demonstration scenario, for instance. So thanks again for watching, and all have a very good day. Thank you very much.